Greetings and felicitations once again, fellow modelers. How you doing? Got a lot in store for you in this video, as always. I tried to pack as much into each one of these videos in small little vignettes as possible to keep it clicking and so you guys don't get bored. We're working on the BC deck, Lance's refit, Lance's cabinet for his bass, Jack's cabinet for his original series bass, and several other things. I do some basic electron current flow, show you the real basics, and several other nifty little things here and there. Anyway, I hope you have fun. Let's get to it.
Excuse me. Okay, let's go over some basic troubleshooting techniques, okay? The first thing you check is, do you have power applied? Is your battery charged up, or is your DC power supply working? Okay, if that's true, then go to the next. Do you have good firm connections everywhere, specifically where your power is applied? Now, that was the problem initially when I built this circuit. As I said, the metal foil had lifted off of the board. Now, this happens on occasion. It's usually pretty rare, but these are composite boards, and they're not as strong as, say, one that's brass etched or copper etched or whatever etched in ferric chloride. They just don't have the strength of the connection between the board and the foil because they're literally glued together. Now, I'll show you that in a minute. Now, if your connections are good, then check the fuse if it's applicable. Now, if you don't have a fuse, then that's irrelevant, but a lot of times it's the fuse. I've worked on electronics for a lot of years now, and I'm here to tell you 90% of all TV, VCR, and other problems are directly related to dirt getting into the system and causing a cross connection where it shouldn't be, or simply a blown fuse or a bad cord. That's literally 90% of all TV, VCR, microwave, electronic repairs are either dirt, a fuse, or a bad cord. Now, if there's no fuse and you've got good connections and you've got a good cord, check your ground. Make sure you've got a good positive ground. If that's true, check your components. Now, on something like this, once I got the connection problem fixed, I had partial operation. Now, these IC chips don't partially work. They either work or they don't. So that told me that I had more connection problems. Now, when I went back to resolder a couple of the LEDs, I ended up getting a couple more working, but there were 3 that just would not work. Again, I have to go back to the board. So, the last thing you check are the components, because in today's mass-produced electronics, this stuff is all manufactured, designed, and engineered to work right the first time. And compared to back in 1958 when the first transistor came out, there's a total science behind this. So, again, check your power supply, check your connections, check your fuse if applicable, and always make sure you've got a good positive ground. Then, and only then, do you maybe go in and look at the components. Alright, so there we are with the basic troubleshooting. Now let's have a look at some more basic electronics. First of all, you've seen me build 3 circuits over the last couple of videos and test them and troubleshoot them. These are the 3 basic circuits: the sound of light circuit, the blinky circuit, and the digital roulette wheel. Now, each one of these circuits, if you've purchased any one of them, comes with a schematic diagram and the values needed to build that circuit. So, I challenge you guys to take any one of the circuits that you may have purchased, or purchase one of these. After you've built the circuit on the board that was supplied, with the parts supplied, go to your local Radio Shack or preferred electronics outlet, purchase the same components and some connecting wire, and build that circuit on a hobbyist board or a breadboard and see if you can't get that very same circuit to work all on your lonesome. Now they provide you with the schematic in each one of these, so I can't see that that would be a copyright issue for you to build your own circuit. Now let's talk about some more basic electronics. We're getting really down to the basics now. These metal strips, these four here, are zinc and these are copper. The zinc has more negative electrons than the copper simply by its molecular makeup. It has what is known as free valence electrons. Now, simply because these are two dissimilar metals and one has more electrons than the other, simply by putting these plates into an aqueous fluid or anything that has a slight bit of acid, whether it's mud, a potato, an orange, or, well, you name it, just about anything that has a little bit of acidity in it. That is considered an electrolyte. This is the basic operation of a battery. Now you've got 4 plates here each. So each one of these, between the 2 plates, if done properly, will produce approximately, depending upon the electrolyte and the materials, approximately 1 to 1.5, 2, maybe even as much as 3 volts apiece. If they produce about 1.5 volts apiece, that's 6 volts. Between these 4, 1.5 volts will give you a 6-volt battery. Now, these plates, just one of these plates, one of each of these plates, is enough to power an LED, a soundboard, or a small digital clock. These are the connecting wires. If I get to it, I will try to do a quickie demonstration, grab a couple of things, and show you exactly. Now, this is just a basic kit that you can get from any science center or many hobby shops. But this shows you the basic operation of DC electronics. DC current flow, electrical flow, what have you. So let me wrap this up here and put together a little demonstration. Shall I? Now if you see here, I've got almost exactly the same voltage that you get from a brand new Duracell battery right out of the pack. And all I've got is 2 potatoes, a couple of plates, and a piece of wire. Now, have you heard about the Baghdad Battery, where they found batteries in Persia? They were clay pots that had apparently been filled with some kind of fluid, and they had copper plates and zinc plates in them. I have always suspicioned or suspected that the ancients were a hell of a lot more intelligent than what we give them credit for. Look how simple that is, and I'm already generating voltage. You put several of these together, you got a 9-volt battery. You keep going, and I mean, figure it out. You've got 12 volts, 24 volts, and so on. And all you're using is plates, natural items out of the ground, potatoes, and wire to make connections. Now we know they were plating gold because we saw King Tut's sarcophagus plated in gold. How do you think they did it? If they could plate gold, who says they couldn't come up with some kind of basic lighting? I mean, come on. I know this sounds like ancient aliens, but you got to keep an open mind about this stuff. Anyway, there you go. Basic electrical theory. Now you saw what 2 potatoes can do. What can 3 glasses of water or 3 bottles of water do? Remember, there's nothing here. There's no salt added to it, nothing. This is right out of our well. Limestone and calcium well water is all it is. So we've got 3 little bottles of water. And look here. We're generating enough power to light a super bright white or super bright red LED. Now it's not at full power, but there's also not enough current pulling through this LED to burn it out. So I'm literally going to leave this hooked up for the next day or two and see how long it lasts. There you go. Basic current flow. Now, I'm showing everybody this because before you can get into any advanced electronics, you've got to get a really firm basis on the basic stuff. And if you get a clear understanding of how the basics work, then you can expand from there. And I'm telling you, you don't have to know all of the formulas. You don't have to know Kirchhoff's law or Thevenin's theorem or any of the rest. All you've got to learn is basic Ohm's law and how the basic components work. Because really, on these starships and other models, whether it's car models, starships, say the Terminator head, light up the red LED, whatever, you're dealing with the most basic stuff there is. So, good luck with you guys. I hope you'll try to take some of this and get something out of it. I hope you try to build your own circuits. I really do. I hope that you see what you can get off the shelf really cheap that you can adapt to your needs. You don't have to pay $150 or $200 or $250, $300 for combined kits to do what you need to do. And trust me, I will get into some more evolved electronics in the next movie. Now here are a couple of other things that you might consider using or purchasing if you're going to light your ships and you have more than a basic knowledge of electrical and electronics. I don't suggest that just everybody does this. But if you're a big boy and you're not afraid to take chances and you're smart, this is a great way to light your ships. This is an old power supply from a computer. And as you can see right here, this tells you exactly what the call out is for each one of the lines. You've got 5 volt, 12 volt, and so on, and they're different amperage ratings. Down here on these ends, this is where you test your voltage with a digital multimeter. This is a digital multimeter. Now if you see here, the yellow and the blue wire are usually side by side. This gives you 12 volts negative and 12 volts positive respectively, which is for a 24 volt system with respect to ground. Now, you can use basic math to come up with multiple voltages by connecting these wires in the appropriate manner. I'll get into that in the future when I do some more work on Lance's base and electronics, but I did want to touch on digital multimeters for sure. Now these come in real handy. They come in digital or analog, and you almost have to have one for checking amperage, voltage, whether it's DC, alternating current, or checking the ohms on your resistor. Say you've got a resistor that you can't really read very well. You set it to the appropriate place on the dial and you check your resistance in ohms across your resistor to make sure that you're reading it right or that you've got the right value. Now I used to have a Fluke, and anybody that knows, Fluke is about a $400, $500 meter. Unfortunately, somebody stole my Fluke off a job site, and I had to pick this up, and I got this cheap, and it's lasted me for 10, 15 years. This is real close to a Fluke with about a third of the price or a fifth of the price. I think I paid $65 for this on sale. And it does everything the Fluke does and more, and it didn't cost $400 or $500. I've learned to shop around. Well, the wife and I have been doing some spring cleaning, so I wanted to show a couple things off real quick. My wife picked up this awesome tripod for $6 at a thrift store, and she just laundered and dried my blue screen and my green screen. I've been talking about putting some things up on green screen, so I'm getting ready to clear a big section out of the garage, mostly the back wall, and I'm going to put up my green screen because I've got a few things I've been promising to put in front of it. For one, the refit build I'm working on. For two, Jack's original series buildup, as well as the work bee that I've been working on and a couple of other things. Anyway, we're going to get to see this tripod. Oh, look, kitty. Professor Schrodinger. You're going to get to see the tripod in action, and we're going to get to see the blue screen and the green screen in action pretty soon. Woohoo! Well, once again, we've got good weather, at least for today. It's going to be a little chillier tomorrow. So I finished up the framing on Lance's refit base cabinet, and I'm going to be doing a little more framing on Jack's TOS original series cabinet for his build-up. So that's where I'm at with this as far as the carpentry. I've laid out a new sheet, and I'm getting ready to do some finish work on both of these. Then I'm going to get back to Lance's refit. Now, I was prepping this to shoot it with a gloss coat of pearl, and I saw a couple of minor flaws. So I went over it with 600 grit wet dry sandpaper, and I used it wet to get a nice smooth even shape on the minor flaws that I could see. I doubt if you can see them here. So I'm going to shoot this with gloss white, and in 15 minutes, as soon as that sets up and gets tacky, I'm going to shoot it with the pearl. Then I'm going to set it aside in a safe place so it'll set up and fully cure for about the next 48 to 72 hours. Okay, this is the bottom of Lance's engineering hall. I've shot this with pearl. It's looking really good. I'm saying it's good. Now I start pulling fiber optics through here and through the part that goes here, place the part here, start Aztecing. I should have this Azteced in the next day or two and have it ready for assembly. Anyway, there we go. At the beginning of the month, I ordered a boatload of electronics to start working on the deflector shield circuit, the torpedo circuit, as well as a couple of other things. I also ordered some 12 volt pre-wired LEDs because it just makes it go so much faster. These are ready to go. All I got to do is connect them to the circuit in each appropriate circuit for whatever their particular use. It cost me 10 bucks for 50, so that's not too bad at all. I didn't have to sit there and pre-wire all the LEDs or add current limiting resistors, so that's a pretty good deal. You can usually find these on eBay for 8 to 10 bucks, maybe a little more. I also ordered another order of about 100 LEDs, waiting for that to come in, and I'm going to have to order yet some more new electronics. So I'm going to be getting deep and heavy into this here pretty soon. I hope to do a little more on the basic electronic side, but this stuff is not the basic stuff. Alright, I've got all these detail parts painted with a base coat and or finish coat. These have a base coat. These parts for the nacelle have a base coat. This has got pearl on it. The back cab of the engineering hull, this has pearl. I'm going to tape this off yet again and add some fine detail to these greeblies on the front of the little hemispheres. I'm going to pull fiber optics through the bridge, glue that in place so that I can run it down through the BC deck, tape the top of the bridge off to add some detail, and I'm going to paint the thrusters on these fins that go on either side of the nacelles. And let's see, it looks like I got a finish coat on the shuttle bay doors. So that's where we're at, and I'll be moving forward on that, and we'll see what it looks like here in a couple of minutes. Okay, we've got the neck painted in pearl, and I just want to get a real good shot of that pearl. Now it's a little wet right now, but as soon as that dries to a hard candy coating, it's going to be easy to work, finish up or start and finish the masking, adding the Aztec pattern. Again, we're going really low key with the whole Aztec and decals and strong back colors, because you just don't see it in the movie. When you first see the motion picture, you just don't see it as bright and loud and garish as some people tend to make these ships. So I'm trying to take a subtle approach. Gotta love that pearl. God. Alright, so after this is fully cured, we'll start Aztecing this. I've got some other detail paint I'm working on. I'm moving forward on this every day that I can to try to get it done and out the door. Here are some 3mm LEDs that are pre-wired for 12 volts. And I wanted to show that underneath, these are all, the bridge that John created is all set up, ready for you to insert 3mm LEDs. So it's already ready for you to wire, and I'm going to come up with a basic electrical kit to go with this, so that you've got the blinky on top and you've got your beauty lighting coming out of all three of these spaces, as well as the interior lighting for the windows and the officer's lounge. I also wanted to show a couple of things that are handy to have if you're doing electronics, and that's these little alligator clips. These come in really handy when you're building and testing circuits. Additionally, a piece of sponge. If you got a piece of sponge like this, you've got capacitors or transistors or even IC chips and or LEDs laying around and you want to sort them out and organize them. I've got this all set up. You can see red here, blue, white, and green down here. So I can keep track of all my stuff in one little handy place, and I don't have to worry about digging through a little parts bin or what have you. So that's another idea. More to come. Well, the wife picked this up for me at a thrift store for $1 or $2. And guess how easy that's going to be to make into an original series prop. I mean, look at it. It's ready to go. All you got to do is remove this clip, modify the back a little bit, get rid of this switch, paint it, add a screen in here. You've already got your power wire run for a miniature picture holder or one of the electrical screens that shows pictures, or hell, you can just tape a piece of green screen in there and mat it up and show your composite your video into the green screen. I mean, this thing's ready to go for an original series prop. Now here's another little something I've got here. The wife picked this up at a thrift store for, I don't know, nothing. And this is going to be perfect for an alert light to go on the work bee when I film the work bee against the green screen. There's always something you can do with the little knickknacks and stuff you find here and there. And I guess it's just the way my mind works. When I see something like this, I've immediately got a use for it.
Basic electron flow with regards to electronics, and several other things. Anyway, I hope you enjoy what you're about to see. I already know what's in it because this is the last thing I'm doing before I edit the video together. Brain fart. I don't know what to say now. Let's get to it. Now maybe I can